Today, let's journey into the cosmos to discover the planet that looks most like cotton candy, the cotton candy planet. Located about 200 light years away in the constellation Virgo lies cosmic scale cotton candy, WASP-107b. It has no solid rocky crust and no scorching metallic core. Instead, the entire planet is wrapped in a fluffy, gaseous envelope tens of thousands of kilometers thick. Its density is even lower than that of actual cotton candy, so light that it seems as if it could be swept away by stellar winds, drifting through the sea of stars. This isn't a fairy tale. It is an astronomical marvel observed firsthand by astronomers, and its discovery was made possible by the transit method of the WASP project. When this planet passes in front of its host star, the star's brightness dips ever so slightly. This tiny, unassuming signal allowed astronomers to pin down this cosmic anomaly. Its host star is a red dwarf, smaller and cooler than our Sun, but incredibly active, constantly blasting out powerful stellar winds. Yet, WASP-107b orbits exceptionally close to its star, with an orbital period of just 5.7 days. Scaled to our solar system, this is like placing Earth 3 times closer to the Sun than Mercury's orbit. At this distance, the star's heat is enough to melt rocks into magma and vaporize liquids. However, WASP-107b defies expectations. Instead of being scorched into a fireball, it has been inflated into a fluffy cosmic marshmallow. When astronomers first calculated its parameters, they suspected their instruments were malfunctioning. While this planet is the same size as Jupiter, its mass is only about 8% of Jupiter's. Its average density is just 0.13 grams per cubic centimeter, less than 1/7 the density of water. This ultra-low density comes from its atmosphere, violently puffed up by stellar radiation. The outer envelope of hydrogen and helium is heated to hundreds of degrees, causing molecules to expand outward. This creates a bloated outer layer over 100,000 kilometers thick, nearly 8 times the diameter of Earth. But what surprises astronomers most is the planet's unique, otherworldly weather. In 2023, high-precision observations by the James Webb Space Telescope not only detected helium in its atmosphere, but also captured traces of silicate particles. These tiny grains, sharing the same composition as sand on Earth, rise with hot air currents, cool, and condense. They eventually rain down, creating a unique sand rain phenomenon. Imagine standing at the edge of this planet's atmosphere. Beneath you lies a feather-light gaseous mist, while golden grains of sand drift through the starlight, and howling stellar winds echo in your ears. This spectacle is far more breathtaking than any sci-fi blockbuster. The cotton candy nature WASP-107b also holds key secrets to planet evolution. Astronomers suggest that early on, it may have had a dense, rocky core, much like Jupiter. But being too close to its host star, its core was steadily stripped away by stellar winds. Meanwhile, its outer atmosphere heated and expanded, ultimately leaving it in this puffy state. Even more fascinatingly, billions of tons of gas escape its weak gravity every year, drifting into deep space. Just like cotton candy slowly melting under the sun, this extreme atmospheric escape provides humanity with an ideal, natural laboratory for studying how planetary atmospheres evolve. Before this, our understanding of gas giants was limited to compact worlds like Jupiter and Saturn. The discovery of WASP-107b shattered those assumptions, proving just how diverse planetary configurations can be. A planet can be a solid ball of rock, a dense gas giant, or even a soft, puffy cloud drifting through the void. It is like a key handed to us by the cosmos, unlocking new possibilities of how planetary systems evolve. When we look up at the night sky, those twinkling points of light are never just cold, sterile symbols. Every planet has a story to tell, and every unique structure hides a cosmic secret. WASP-107b, this cotton candy world 200 light years away, reminds us that the universe never runs out of wonders. It only lacks the eyes to find them, and the courage to explore the unknown. Deep within the boundless sea of stars, there will always be wonders beyond our wildest imagination, waiting for us to unveil them.